section 3.7 on the power rule and the chain rule. So what we're actually naming this is the generalized power rule. So this is also known as the generalized power rule. Why generalized power rule? Because instead of taking derivative of just the variable to power n with respect to that variable, we're going to take the derivative of a function to power n with respect to the input of that function. And so what happens is that multiple times we try to basically take function g of x that was differentiable, and in this section we've tried this multiple times, and for any n we took a derivative of that function to power n. And if you take the derivative of a function to power n, it's going to be n according to chain rule times u to power the function to power n minus 1 times the derivative of the function with respect to x. Or other ways of expressing this is d dx of, let's say, gx to power n is going to be equal to n gx to power 1 less times derivative of gx, g prime of x. And that's the power rule. And it's important for us to basically be very comfortable with generalized power rule. Example 5. Take the derivative of x to the third minus 1 in parentheses to power 100 and with respect to x. So how do we start with this? First, I have to recognize my g of x. G of x, or u, is g of x is x to the third minus 1. And therefore, when I'm computing this, it's the 100 will go down, then g of x unchanged to power 1 less 99, then derivative of g of x with respect to x, which is 3x squared. So this way it's sometimes easier than the just to think of it this way than how we think of it in chain rule. It is a chain rule, but this is easier to memorize and work on basically. So multiplying that 3 and 100, also you get 300, and x squared, x to the third minus 1 to power 99. Now the second part of the example. Now this one is also a generalized power rule. How come? Because g of x, or in here we called it f of x, is to power 1/2. So this entire thing is saying the f of x to power 1/2. And so the derivative is going to be 1/2 f of x to power 1 less, which is negative 1/2, times derivative of f. And if you bring the f of x to power negative 1/2, it comes to the denominator with the 2. I click here question 4. Let h of x be square root of 7 plus 6f of x. Suppose that f of 4 is equal to 7 and f prime of 4 equal to 2. Find h prime of 4. Options are A 6/7, B 12 seventh, C 7, D 7 sixth, E not enough information. So you took a break and solved it and came back. That's what we're hoping. If you haven't, pause it. And so what you do is, first of all, I realize this is 7 plus 6 f of x to power 1/2. That is, g of x is this function. G of x is 7 plus 6 f of x. And g prime of x is equal to, derivative of 7 is 0, and derivative of 6 times f of x, 6 is a constant coefficient, is going to be 6 f prime of x. Now, g prime at 4, is going to be 6 f prime at 4. Now, the other part is that we're not really finding g prime at 4. We're finding h prime. So we're trying to find h prime at 4. So I have to find h prime of x first. H prime of x, this is the side note that we used, but h prime of x is going to be, according to this, is going to be 1/2 inside unchanged to power 1 less times derivative of g of x, which derivative of g of x we found here is, over here is 6 f prime of x. Now, 6 f prime of x, if you clean this up, you get h prime of x is equal to 3 times 7 plus 6 f of x to power negative 1/2 times f prime of x. Now plug in 2 for the for x. Plug in 4 for x everywhere that you see 4. So h prime of 4 is going to be 3 times 7 plus 6 times f of 4 is 7 times f prime of 4, which is 2. 6 times, this is 7 plus 6 times 7, which is 49. So it's, this is 6 times 49 to power negative 1/2, which is 6 divided by 7, and A is the answer. I click here question 5. Suppose that y is equal to 5x squared and derivative of x with respect to t is equal to 3. When x is equal to 4, what is the value of derivative of y with respect to t? Option A, 12, B, 80, C, 120, D, 15x squared, E, not enough information. So let's pause and come back with the solution. So in here, we're trying to find, and we know y as a function of x and x as a function of t. So dy dt is going to be equal to what I do is 5x squared when x is equal to 4 So I know that y is a function of x and x is a function of t. So I write dy dt. By chain rule is dy dx times dx dt. Now the question is, dx dt is given and it's a constant basically. So that's taken care of. It doesn't tell me anything about what time they want the dy dt. They're telling us at what x value they want us to give dy dt. And so that requires finding y prime first, y prime with respect to x, and that would be 10x, and then plugging in 4 in there, it gives me this one evaluated at x equal to 4, x equal to 4 is going to be equal to 40 times 3. 40 times 3, which is 120. So you have to be careful and follow what variable goes into what function. Often the outer one, if they give you a derivative, you have to make sure that you're plugging in the right variable in the outer one and the right variable in the inner function. So we have done a tabular form for derivative rules in that we had before. Now graph form of examples also exist, and so the graph gives you a little bit more information than tabular, and you can write the graph. And these two cases, graph of f and graph of g, are given, and basically you know they're differentiable everywhere they are line, and you know that they're not differentiable at this places, and the rule of the two functions are going to be basically piecewise defined. And now not only you can basically in points that it makes sense, mainly when the domain works for the derivative. Remember, these are not elementary functions, so you have to be careful. And so when it works for the domain of the derivative is defined, you can do function operations using the two graphs, with the two graphs. And one of them is composition, now that you know the chain rule. So let's see. I don't even have to write the function itself, which is not that difficult. The function itself between f between 0 to 3 is basically y equal to x plus 2, and between 3 and 5 it's y equal to let's see, you have to plug in the points and figure out. I can see the slope is -1, it's -2, and I can see that it goes through point 5 and 1, and I can find what line this is, right? And so it's not hard to write the function itself. But what to notice in here is that the derivative of the function is easier because it's just the slope of the line. And the slope of the first piece between 0 and 3 is just 1. Slope of the second piece from 3 to 5 is -2. So f prime is 1 between 0 and 3, and -2 between 3 and 5. Oh, what about 3? It's not defined. And so now same thing goes with g prime. between 0 and 4 is negative 1/2, and at between 4 and 5 is 1. That's the slope of the two lines. G prime is easy to find because the derivative is just the slope of the two lines. And it's not defined where the two lines meet, because then that's not elementary function in that area, in that locality. And so now let h of x be f of g of x. F of g of x. Find h prime of 2. Okay, what is a person to do? So first step is to find, and again I said it complicates things too much to find the functions themselves. Just find the derivative, and let's go with the graph wherever you want a value for the function. And so now find h prime of 2. H prime means I have to do the chain rule with f of g of x. So I do a chain rule with f of g of x, and we end up with h prime of x equal to f prime of g of x times g prime of x, right? So if I plug in 2 in there, what do I get? I get 2, h prime of 2 is equal to f prime of g prime of 2 and g prime of f prime of g of 2 and g prime of 2. Wait, what is g of 2? G of 2 is a value in here, right? 2. So I start from the inside again. G of 2 is going to be 4. So G of 2, the entire thing is 4. And that's how basically that we move on. We find f prime of 4 times g prime of 2. And f prime of 4, according to this, is negative 2. G prime of 2, according to that rule, is negative 1/2. And that gives us 1. Right? Example 6, part 2. Let's calculate h of x, h prime of 2 for h of x when h of x is f of x squared times g of x plus 1. Something that I want you to notice is that in here basically there's a product rule going on, right? Two functions multiplying each other, but each function is basically will require a derivative of each one of them requires a chain rule. So that's important to know. So where we start with a function derivative of 1 times 2, then 1 times derivative of 2. And derivative of 1, according to chain rule, is f prime of x squared times 2x, then multiplied by the second one. Then it's going to be first one times derivative of the second one according to chain rule is g prime at x plus 1 times derivative of x plus 1, which is 1. Now plug in 2 for x in here, and you get f of 4. Plug in 2 for x in here, and you get g prime at 3. And 2 times x is going to be 4, and you get f prime at 4 and g at 3. Now, what is f of 4? F of 4 is right here. is equal to 3. What is g prime of 3? G prime of 3 is right here. What is f prime of 4? F prime of 4 is right here. And then g of 3 is this value, which is 3.5. And we replace, and we arrive at the solution, which is negative 29.5. I click at question 6. Let's do iClicker question 6. Let h of x be f of g of x minus x, where the graph of f and g are the same as the graph of the previous problem. Find h prime of 2. Option A, negative 3/2. Option B, 3. Option C, 3/2. D, not enough information is given. And so pause and solve and come back. Now that you paused and solved, let's see. First thing first, this is a chain rule. H prime of x is equal to f prime, and the derivative of the outer function evaluated at inner unchanged times derivative of inner. What's the derivative of g of x? That's g prime of x. What is derivative of x? 1. And then evaluate that at 2. We were finding h prime of 2. So that would be f prime of g of 2 minus 2 times g prime at 2 minus 1. Now, what is g of 2? G of 2, let's see, this is g of 2 is 4, so this is 4. And g prime of 2, g prime at 2 is the slope of this line, which is negative 1/2. Now, what is going on is now this simplifies to f prime of 4 minus 2, which is 2, times negative 1/2 minus 1, which is negative 3/2. Now, f prime at 2, where's f prime at 2? F prime at 2 is right here. The slope of the line is 1. So the entire answer is negative 3/2.